So, welcome to The Luddites Were Right, or the Lightening talk, if you'll forgive me. So, today, Luddite is generally an insult, but we don't teach who the Luddites were because that might imply they had a point. And that's only because powerful interests made it that way. This tonight is a brief history of the Luddites, and maybe you'll see a little bit why they did what they did, and why maybe we should be seeking to emulate them a little bit more. In 1799, the British government outlawed unions and collective bargaining across the entire United Kingdom and the burgeoning colonies. Of course, this could never happen today. Please don't look at the news. But factory owners responded by slashing wages, increasing workloads, employing fewer people, and they bought more looms, the main industrial output of the United Kingdom at the time. For a decade, workers tried to negotiate peacefully with the mill owners to very little benefit. It turns out when you can't negotiate as a group, nothing happens. So in 1811, workers destroyed looms and other equipment in a coordinated attack orchestrated by King Ned Ludd. They called themselves the Luddites. They were the skilled workers being put out of work by the greed of the mill owners. Thing is, King Ned Ludd never existed. But the government searched for him in vain anyway, and it gave them important time to coordinate their protests. They picketed, they wrote letters, they won the support of the communities they lived and worked in. They called for better wages, better work, and the end to child labor. They were literally being worked to death. In response, the government sent 14,000 troops to protect the mills, to quell Luddite protests, and to force them back to work. Frame breaking, the act of destroying a loom, was made a capital offense, and ultimately the leaders of the movement were found, tried in sham trials, and ultimately executed. But they won. Ultimately, they won concessions in terms of better working conditions, better pay, a reduction but not an elimination of child labor. The government and industry fought to paint them as against progress because, unfortunately, their tactics worked for the mill workers or mill owners. They just wanted their fair share of the fruit of their labor. They were not against the looms that made their industry work. They just didn't want to be worked to death at the hands of the mill owners. Today, we see people called Luddites being called Luddites for refusing to embrace new technologies. But we're also seeing a new wave of capital taking advantage of workers and using technology to suppress us. We see it in generative AI, stealing from artists and writers. We see it in abusive tailorist management in warehouses. Think Amazon dogging you for going to the bathroom. We see it in the Orwellian surveillance in workplaces. I don't know if any of you have the abusive workwear on your laptops, but it's the same thing, just a different decade. And the precarious gig economy contracts and robo-firing, think Uber firing workers just because the app says no. None of this is inevitable. And together, if we work as a group, we can fight back. When technology encroaches on labor, be a Luddite. Say no, work together, join a union. Because together we are strong, we have power. And as the Luddites showed us, they need us more than we need them. Thank you very much. I am running ahead of schedule.
Thank you, Connor. Yes, I accidentally bought a book on the Luddites once. It was called Rebels Against the Future, and in the 90s they gave it a sort of cyber cover with green text on a black background, and so I thought it was about technology in some way. Well, it was, but just like 100, 200 years ago. It was a good book, highly recommend it. So we have our next speaker now, Irina. If you'd like to come to the stage, I know you've got no slides. Irina is going to give a talk called Welcome to the World of Table Football. So,
see if this works. Yeah. Okay, cool. So just before I begin, I just wanted to say how much I actually detest public speaking, which is part of the reason why I'm doing this. And thank you very much. Yeah, so as you can see, I have no slides, so you'll just have to make do with my face, unfortunately. So my apologies for that. My name is Irina Razonjnari. I work for Octopus Energy, and I work for the R&D department over in Slough as a controls design engineer, and I am standing in front of you to obviously not talk about that at all. So I want to talk about something that's very dear to my life, and that's played a huge part in my life as well, which is table football. So so something that people don't know about me is that I represented Great Britain at the Table Football World Cup, and also, thank you, and also I played in the Women's World Championship as well. So how did I get involved? So I moved to Cambridge for my PhD, and I immediately joined the University Table Football Club, and fairly soon after that, I became president. I got involved with doing trainings and matches, tournaments, locally and also nationally and internationally as well. And essentially, so the women's Great Britain captain, at the time, she lived in Peterborough, and whenever we held tournaments, so she would come to us, she would come and participate in our tournaments because geographically we are the closest club to her, and basically that's how we met, and she saw me play, and obviously she liked what she saw. Which brings me to the main point of this talk, is to kind of give you the exposure to competitive table football, because whenever you mention table football, people think of that game you play down the pub or during your lunch break or something like that. So just to make you aware that there are communities out there that do take it seriously, that properly sweat during matches. And my advice would be to, if you want to get involved, is to join your local club. So if you go on the British football website, there will be a list of clubs, active clubs on there, and make sure you get in contact with them. We are very friendly. We're always eager to get new people. Like, don't be afraid if you think you're not good. There'll be people there to help you improve or to teach you techniques as well. But just be aware that there are obviously proper rules around it. So to give you an example, during one of the World Cup matches, I got penalized for time wasting because I held the ball for too long, because I kept trying to readjust the ball under one of the feet of the players, and because my hands were shaking so much, I was so scared and stressed and everything. I couldn't do it, so I tried to readjust, and I couldn't do it in the end. Yeah, I agree. I was totally shaken up after that. Obviously, I lost. So just to make you guys aware that this kind of stuff does exist, and it is really fun. We are very friendly. If you want to match, if you know a pub with a football table around here, I'm always up for a game. Obviously. So that's all I wanted to say. Thank you very much.
Fantastic. I happen to know that was Irina's first Lightning talk, so big congratulations to Irina. That was fantastic. Thank you. So now moving on, it was my great pleasure to introduce Becky Smith, who's going to give a talk called Coding Your Health. So a big round of applause for Becky, please.
Hello, I'm Becky. Can you hear me? Yes, good. I'd like to introduce you to the weird and wonderful world of clinical coding systems. So I'm a software developer at the Bennett Institute. We are a cross-disciplinary team of clinicians, academics, and software developers. And amongst other things, we work on a thing called OpenSafely, a secure analytics platform for NHS electronic health records. And our goal there is to make access to NHS patient data open, fast, and reproducible while protecting patient privacy. So if that sounds interesting, we're sponsoring. Please come talk to us outside or drop us an email at that email address. So what we built in OpenSafely is a series of open source tools that enable a researcher to write analysis code without ever having access to the actual patient data. All research code is required to be on GitHub, and everything's open by default. The part of the platform that's most relevant to what I'm talking about today is called Open Code Lists, which uses clinical codes to help researchers define the characteristics of the patient data that they are interested in. So, what are clinical codes? When you go and see the doctor, they'll enter information onto your electronic health record, and they do that using codes from a systematic coding system. One of the most commonly used and extensive coding systems is called SNOMED CT, and it's a huge hierarchical catalogue of concepts containing over 500,000 codes. So you might go to the doctor with a cough. They might also record it as complaining of cough. Then they'll ask you some more questions about perhaps whether you cough after eating or at rest, while you're doing exercise or when swallowing, whether you also have a fever. Maybe along with that, they'll also record whether you have a sore throat. And as well as clinical findings and disorders, SNOMED also has codes to allow clinicians to record things like relevant places, objects, and occupations. Open Code Lists is an element of the Open Safely platform. It's a Django site, and it's built to allow researchers to create, share, and maintain code lists. What do we mean by code lists? So researchers use code lists to describe a particular disorder or area of clinical interest. So, for example, they might be interested in adults who have a diagnosis of asthma, but there are lots of codes that describe asthma in some way. Not all of them correspond to a current diagnosis. So, for example, this code list contains lots of codes under the asthma category, but it excludes a code for childhood asthma. Open Code List lets you build a code list by searching for codes. The search strategies are stored, so we have a record of how the code list was created. So here I searched for cough, and I can choose to include or exclude certain codes or categories of codes. That's all very useful. But what's really interesting about SNOMED are some of the weirder corners of it. If a clinician wants to get a new code into the UK version of SNOMED, they can go to this website and submit a request. This means that there can be some somewhat unexpected things in SNOMED, and the reason they're there is because a clinician somewhere has had a valid use case for them. It has, for example, a section on casseroles, which begs the question, why? What did someone do with a casserole that required it to be entered as a code in SNOMED? Did they burn themselves with it, poison themselves, drop it on their foot? And why only vegetable ones? Sticking with the food theme, there's a surprisingly extensive classification of puddings, although it's strangely incomplete. So sponge pudding is classified into its narrower and very British child codes, but it has some notable omissions. So surely someone somewhere must have injured themselves with a sticky toffee pudding at least once. Some codes... Some codes really do make you wonder what happened for them to get in there. And this is completely unrelated to the fact that I'm married to Mark. Completely. Accidentally caught an ironing board? I think I need to know more. There's a detailed breakdown of different ways to trip on things, or to be intentionally tripped, and yet an oddly ambiguous standalone code for tripping. Gardening is apparently a rather dangerous pastime. We're in Cardiff, so obviously I had to look up dragon. And it's somewhat concerning we need this depth of classification for events related to being sucked into an aircraft jet. So, if you're interested in learning about more about the good work we do at Open Safely, have a look at our website, our docs, our GitHub repos, everything is open online. And thank you.
My wife, ladies and gentlemen, I have never forgotten our anniversary. Moving on, I think, are you set up? I see a black, you're okay? So, in that case, I'm sorry, I didn't get your first name, but you're going to give a talk called Let's Get Introspective. Is that correct? Yeah. Excellent. Oh, not quite ready. This is what happens when people shut their laptop after everything's set up. So, Actually, this is perfect. Yeah, if you'd like to come to the stage to give a quick introduction to the EuroPython Society, an organisation that is very close to our hearts at PyCon UK. So,
hello, everyone. So I got a 30-second slot only, so I'll be really fast. So my name is Mia, and I'm from the EuroPython Society. Who are we? So we organize the EuroPython conference, and also we help local European communities. How can we help you? So if you're a conference or meetup organizer, you can apply for a grant. And if you want to attend or speak at EuroPython, you can apply for FinAid, so basically money. How can you help us? If you enjoy EuroPython, you can join our organizing team. For more information, you can visit our webpage, or you can come and talk to us. We have a stand in the hall, and we will be there the whole day, and we will be really happy to talk to you. Thank you.
thank you. How much better was that than a tractor joke that you already heard anyway? So anyway, let's get introspective. Take it away. Quick round of applause, please.
Hi, I'm Kevin. I am a nerd who works at Dyson, and coming from a compiled source code world, there's a few things that keep me up at night. So firstly, some of the really fun quirks of Python, and also the introspective nature of Python and the headaches it causes kind of developers and package maintainers trying to secure their code, and also some of the quirks and anti-patterns that I've seen where developers have tried to obfuscate and hide their code. So I've made this deck drinking far too much coffee, so I'm not even going to try and kind of jump into the debugger. Google and Stack Overflow says that no one's really tried to fix this. There is some kind of like libraries out there, and I'm not going to kind of say which packages that I've seen some of these kind of weird nuances in. So can security against kind of function introspection really work in a dynamic world? Well, no, not really. So I'll show you some anti-patterns, and I've really yet to see a kind of a good, cohesive approach. If there is, if any of you have kind of seen a great package or approach, kind of come find me. So let's go off to the dictionary. Introspection, that's quite meta, so let's kind of convert it to the Python world. Everything's an object. Everything, i.e. objects, can be inspected, and pretty much everything is mutable. We can kind of change the world around us, and that makes things fun for security. So I'm going to talk a lot about the code dunder, kind of hands up if you've like interacted with it, kind of manipulated stuff in it, inspected. Pretty much most people, it's a laugh. So the first fun that I've seen is by using like get members or dir, you can kind of go into a package and then you can find all the members, you can find functions, and then you can find properties. So for example, a property where they're kind of checking, going, is somebody an admin, is somebody not? Well, that's all well and good, but you can just kind of overwrite their function with your own, and so you can completely claim that I'm totally legit an admin, and thus you can just bypass a lot of security checks. Not really great. That's kind of the first anti-pattern I've seen. The next one that I've seen is them believing that the kind of world is safe, and so they're kind of going off, maybe getting some kind of very secure, secret credentials that shouldn't be leaked out, and then they're just passing them around as variables. Well, they seem to forget that you can kind of decorate functions, and you don't need the syntactic sugar of using at above your function. You don't need access to the source code. You can just go straight in, plug your decorator in, and then the thing with decorators is, of course, you can kind of manipulate the inputs to a function, outputs to the functions, but also you can go and inspect what the parameters are and the variables being passed, so you can just go yoink with people's username and passwords. Not great. So then what I've started to see in certain libraries is where they're trying to kind of almost do self-imposed checks. So for example, when you wrap a function, it'll update the wrapped dunder, and so then you can actually just see whether your own object has that attribute, and then you can kind of try and do some prevention. That's not really that kind of great, and that kind of starts peppering your code with redundant checks. So let's call in the big guns. The disassembly framework in Python. Well, you can just pass in the function, and if you don't know that Python gets compiled into a bytecode and that gets interpreted, but you can look at all the opcodes, and if you look here, that's the actual opcodes for doing that verification check. So what we can actually do is, by kind of knowing where in that code block that check is doing, you can just slice it out and then just stick it back in again. All well good. So now we've kind of completely bypassed that check. Not great. So how can this be solved? Well, teams are really good already at writing spaghetti code, so you just kind of obfuscate even more. There's tools to kind of like try and add obfuscation to function name parameters, but not great if you've got an open source library. Add more checks in, but that'll slow down your code. And then some things, so Dropbox kind of would freeze their code. So what that means is they'll compile their code and then they run it in a sandbox, so you can't hook in a Python environment. Not great. So my main takeaway is, well, security is hard. Thank you.
Four minutes and 55 seconds. That is very professional. And now, moving on, we have a talk. I'm afraid I don't have your name down, but we have a talk which proposes the question, have you ever looked at the PyCon UK logo? So another quick round of applause, please.
So, have you ever looked at the PyCon UK logo? Some of you may have got it on your badge if you've been like me and decorated your badge. It's the little crown at the top here. And this question came to me this morning when I was joining some friends in the newly met friends, I might add, in the rooms with the stickers, and somebody asked, "What's this sticker?" I was like, "Oh, I think it's the PyCon UK logo." And then I started to look at it. I've never really paid much attention before. It looked like a crown, and I was vaguely aware that it had some kind of Python resemblance to it. And I'm not talking about these snakes, although they are very excellent. These are wonderful. They're very, very simple, but still somehow manage to be adorable. No, I'm talking about this crown. So if we look carefully here, we can see there's quite a few little nods to Python in the middle. Obviously, the jewel on the top is a Python replacement for the morally ambiguous jewel and the British gems. Then in the center here, we've got the .py, and then we've got another Python logo. And something that I only just about spotted on my tiny sticker is the edges of these decorations around things are actually little snake heads. And I just love details like this. If you look at logos for big companies and big famous products, you'll see that there are lots of little details. Somebody mentioned earlier the Toblerone with its bear hidden in the mountain. And if you've never seen this, by the way, you'll be blown away. It is amazing. And it just made me think that logo design is, and graphic design as an extension, is something that is absolutely incredible. Anybody who will have ever developed a product or been part of a business or anything else tell you that branding is so important. And logos are a huge part of that. And I thought that it would be appropriate to take a moment to appreciate just how well designed this logo is and pay homage to the wonderful graphic designer who put together not only this logo, but all of the other logos that we see every day and don't appreciate. Thank you.
I was contemplating that so much I nearly forgot to come back onto the stage and introduce our next speaker. Mark is going to talk about Python in Excel. Take it away, Mark. Big round, quick.
Thank you very much. My name is Mark Rochell, and I'm here to talk to you about the new Python in Excel. I'm not affiliated with Microsoft. I'm just a nerd who loves both Python and Excel. So there's Python in Excel. Yes, indeed. A month ago, yesterday, Microsoft on their blog announced that the world's best programming language was going to be integrated with the world's most popular spreadsheet. If you Google Python in Excel, you can read that. But what on earth would that even look like? Well, this is what it looks like. And now millions of users around the world will have the Python logo in the middle top of their screen. And they'll be able to click on that button, and instead of a cell being an Excel cell, it will be a Python cell. Just like in a Jupyter notebook, you can put code in there using any of your favorite libraries, pandas, NumPy, matplotlib, etc. And you can reference values in the spreadsheet, you can reference ranges in the spreadsheet, you can reference other Python objects in the spreadsheet, and you can return values, you can return tables, you can return images. This is very much a huge integration, and if you're an Excel nerd like me and a Python nerd, this is pretty exciting. But should you use it? Should you care about this? Well, I'm not certainly suggesting that most of you start integrating spreadsheets into your production stack. But I think we're all used to using Python not just as a scripting language, but as an interactive tool in things like a Jupyter notebook. Not for necessarily production code, but for investigating data, for building models, for trying to understand things. And I think Excel will provide an extra sort of a tool to this family of how you can use Python to model things. And I think there's a spectrum here, and there's kind of some ideas of what should be on the ends of that spectrum. So clearly, Python is very interactive. If you change the value in a cell, everything else cascades down, and all the other values update. You don't need to rerun the code. You don't need to do anything. It's all cascading down for you. And so when you're modeling, whether it's the domain or messing about with your data, spreadsheets are a very declarative paradigm. You don't define control flow in a spreadsheet. You define the relationships between objects, the relationships between data. And I think for a lot of modeling, that is going to be a really interesting way of using Python, and not necessarily the natural way we use Python at the moment, which is quite imperative. And also, spreadsheets are nonlinear. It isn't a case of code at the top runs before code at the bottom. You can put objects, data, code side by side. You can put it diagonally. You can add word art to your code if you want to. It's a way of modeling that potentially for some use cases I think would be quite useful. But is this good for Python? Well, I want to talk about business users, the people in your organizations in HR or accountancy or maybe in marketing. They have Excel on their desktops, they use it every day, but what do they reach for when Excel isn't quite good enough for them? Do they pick up the phone to IT and say, hey, can I get a Java installation or a Python installation on my computer, please? Well, even if they've heard of those things, IT will say, no way, we don't give those things to end users. So what do they reach for? They reach for the only thing they can, unfortunately, VBA. Well, what are they going to reach for now? They're going to reach for that thing that was right in the middle of the ribbon. They're going to reach for Python. And millions of people in the world who are not the type of people who normally would be in this room, perhaps next year some of them will be. And I think that's a really good thing for Python. Thank you.
Thank you, Mark. That is 6 talks. We are halfway through our evening's program. It's so good to hear you keeping the energy up. It's fantastic. Thank you so much. And it is now my great pleasure to introduce Tom Gregory, who is going to show you his 5 least favorite graphs. So a quick round of applause for Tom, please.
Hello, conference. This is my first PyCon, and everyone's been so friendly, so big thank you to the organizers and everyone who's making this all work. Conference, I have a confession. I'm an addict to bad data visualization. And I have a lovely collection, and I'm going to show you a little peek behind the curtain of some of my top 5 worst graphs today. Here is one of my favorites to kick you off. They've done some good work here to show you the average female height by country. Scaling heights by area is an interesting choice. And I'll just tell you now, I'm 6'6", so to keep your dreams safe tonight, I've not put myself on there for scale. It would have been monstrous, some kind of gargantuan thing leaping out of the screen at you. Yeah, it's I'm sorry, India. It's a very interesting design choice. Okay, let's move on to the next one. What do we got? This is some people love this, some people hate this. Teen pregnancies, statistically speaking, they really drop off a cliff at the age of 20. This might be definitional. But for those of us looking for the subtler points, I also actually just hate the fact this is a line graph when these are all clearly discrete buckets. But hey, we'll take the easy points too while we're there. And whilst we wander through these, I kind of want to make the important point that these are important questions, right? Presenting data to people who don't understand it, who don't see these things straight away, it's important for getting the message across in a non-misleading way. And certainly by the time we hit some of the later ones in this collection of my favorite graphs, sometimes the misleading is being done maybe a bit more deliberately than it should be. What do we got? Yes. 6 years ago, those added up to 100%. Yeah, this must have been a Fox News or some such. Just do some basic checks, please, if you're presenting data to people. I mean, gosh and golly. I know the one I've got next. Yeah, it's going to take you a moment, right? But so I'm just going to leave it on the screen. I'm not going to say anything for it, but I want you to stare at it. It's oil production, the UK compared to the whole rest of the world, so natural oil production. And at first, it's almost got some kind of magic eye quality to it, right? Like, it's very obvious something is very wrong here, where the UK is being compared to the rest of the world. And you think, is it the fact they're stacking the graphs? That's a good way to distort things. Oh, the scale. The logarithmic scale. So logarithmic scales are usually great. Please think carefully about your use of a logarithmic scale before you just whack it on. Just don't go straight for that matplotlib log option. Put some thought into your graphing choices before you do it. I'll take a minor tangent before our final graph from my collection today. And it's a brief discussion about local politics. Because I need to put my hands in the air and say that I am a local politician as well. I'm an elected councillor. And in many ways, being a local councillor is much like being a Python dev. A lot of people are complaining a lot of the time about a lack of garbage collection. So with that in mind, I want to have our final graph be from one of my favorite categories of misleading graphs. We affectionately call this the LibDem bar chart. You'll find this on your election literature around the country in any competitive seat in any April of any year or whenever the current government of the day decides to hold an election. You'll notice these bar charts are not exactly proportional to each other. I'm sure the Lib Dems are very close to the Conservatives in this particular seat. And then Plaid's got about the same distance again, but the numbers just don't add up for that at all. So thank you for having a look at some of my favorite non-favorite graphs. Please, I think that there is a serious point in there of do look at your data visualization, do make sure it all works, do make sure you're not being misleading, deliberately or not. But do keep an eye out for the good ones, please, and send me anything you find. Because these are all in the wild, right? These require people like us to go hunting for them and publicize them and enjoy them when we find them. One final plug and shout out in that I am looking for work at the moment. I'm finishing a PhD, so if you happen to be hiring or want to connect, come find me. My LinkedIn's on the Maths in Motion talk that I gave yesterday. Sorry for the final plug, but do enjoy. There we go.
Tom Gregory. Thank you very much. That was fantastic. I do like some comedy graphs. And so now I'd like to introduce our next speaker, Jordanov, sorry, who is going to give a talk called The Hitchhiker's Guide to Benevolent Non-Dictatorship. A round of applause, please.
Hi, I'm Jordan. I write Python at a company called Blue Prism. I'm on LinkedIn if you want to connect. I write stuff on Medium. And if you want advice on how to skip leg day at the gym, find me on Instagram. And I want to start with this, man. Our benevolent dictator for life, the dear Guido, right? So, me being from Eastern Europe, I don't like dictatorship so much, so I was kind of thinking of how to get rid of this aspect. And to do that, I asked my favorite book, which is Hitchhiker's Guide to the Galaxy, and it unfolded into a 4-step process. Now, the first thing is you want to create a vision, right? You want to have a destination where you want to lead people to, and you want to be able to do that. So before leading anyone else, you must be able to lead yourself. And to do that, it's really important to keep a balance between what is easily achievable and what is kind of pushing the envelope a little bit. So you kind of want to be sitting at the edge, not kind of falling, but staying in place as well. Now, second thing is to get people on your hype train. And that kind of concerns the skill of communication, which is an art in itself, but I've kind of outlined two main aspects in it. And first one is to kind of know your audience and how to pitch at that level. So you want to kind of address certain problems with certain people with a certain language. And the second one is to kind of define what's in it for them. Because you could be very excited about a certain idea, implementing it, because it's our big way to make everyone's life 1,000 times better. But if you don't explain why that is and what value it will give to other people, no one would pay attention to that. And instead you want to, as I said, kind of formulate the proper kind of message to them. The third step is to turn your vision into a mission, which could be achieved with your team. And these mainly concerns are like managing, steering direction, being able to respond to change, being able to give feedback and take feedback as well. And the fourth part, which kind of makes it the benevolent part of it, is to kind of make a positive environment by encouraging everyone for their successes, making sure they're having the right tools to do their job, and to mentor them and maybe inspire them to become leaders themselves, because leadership is for everybody, and that's kind of would make our life more productive, really. So, yeah, whatever happens, don't panic.
Thank you so much. Was that is that first lightning talk that you've given, Jordan? Yeah, so first time speaker. Big round of applause, please. So now, moving on quickly, we're on time, it's amazing. So Mark Shannon is going to give a talk about building a debugger in 4 minutes. In 5 minutes.
1 minute thing. Okay. Right, before we start this, I'm just going to start PDB on a longish program. So let's press C, off we go, and we'll come back to that later. So, building a debugger in 4 minutes. Well, I'm not going to do that. I'm just going to show you some code and explain it in 4 minutes, and then we'll see what happens. So, in Python 3.12, we're adding a thing called sys.monitoring, which is a more faster and flexible API for monitoring aspects of a Python program. If anyone, hand up anyone who has used sys.setTrace or sys.setProfile. That's more than I was expecting. Okay, cool. So this is a more flexible and much faster approach. It's also slightly lower overhead when you're not using it as well, which is part of our motivation for doing it. So I'm going to implement an incredibly simple debugger, which is basically just going to have a break command and nothing else. All the stuff about introspection and visualization, all the actual useful stuff in the debugger. Yeah, well, I won't bother with that. So, whoops, touch screens. Not to be touched. Where's my mouse gone? I can try your touch screen. There we go. Hey! Right, so that's still running. Yep, good. PDB's not so fast. Right, okay, so let's find the debugger itself. Okay, so very simple. We're going to have just a set of breakpoints and a little function that just adds, if we give it a function name and a line. Normally with a debugger, you use a file name and a line, but there's less code to use the function name because we don't have to do all the messing around with absolute paths and local paths and all that sort of stuff. So a little run function to run the program. Now this is the key thing. What we have in this is a callback function. So what we can do is we can say, for every line, call back a function that we give to the monitoring. And this callback function basically checks to see if it's a line or code that we're interested in. And the key thing here is where it says we're not interested in this line, it returns a disable. And that says to the virtual machine, we're not interested in these events anymore. And that is really important because what that allows us to do is for the code to run at full speed unless we hit a breakpoint. And we'll see the effect of that in a second. And then the rest of the code is just, I got to just register some stuff, some boilerplate, so I need to give it a name, so it shows up for introspection, register that callback, set the events, and the event we're interested in is the line event. And then the rest of this is just a little a hacky command line interface, which just looks for run, break, and quit commands. So let's try that out. Note that's still running, that's PDB going slow. Okay, so first of all, I want to try this on the short version. And so let's set a breakpoint. So we break and the loop function. Oh, actually, before we do this, let's have a quick look at the function we're playing with. So here's our little code. It just loops 1,000,000 times. And note that on 1 out of the 1,000,000 times, it hits line 4. So we're going to stick a breakpoint there, and that's kind of key. Because the way currently PDB works, it works on top of setTrace, and that basically has to do a lot of work. Every line it has to check constantly. But because our debugger can basically disable those events, we only suffer the performance impact on the 1 in 1,000,000 time it actually hits it. So let's go back to our example. Oh, PDB's finished. That was faster than I expected. Okay. Okay, that didn't take quite so long. Am I running out of time here, or have I just mistimed this program? Okay. You were supposed to give me the minute thing. I was supposed to go show PDB work. Okay, cool. Let's do this quickly. So there's our breakpoint, and then we run, and it's reached it almost instantly, and then we quit. And then let's try the long one, the one that PDB took a few minutes on. Oops, long. And then we have breakpoint again. And we run, and it takes 1, 2, 3 seconds or so. And then we quick. So yeah, we have this running at full speed. So it's basically what would under PDB take a minute takes a second, or what PDB would take an hour takes a minute. So I think that's it. Yeah, we're supposed to go back to PDB at this point, but it's already finished, so that's cool.
Big round of applause, please. Thank you very much. That is very cool. So now moving swiftly on, it's my great pleasure to introduce Claire Spencer, who is going to tell us how to talk to non-devs. So a quick round of applause for Claire, please.
Hi, my name's Claire Spencer, and this is my brother, Paul. He's the reason why I'm here. He went to a conference like this, and a speaker said, "Teach your sisters to code." He then met up with me on Skype, that's how long ago it was, and every Sunday, and tried to teach me to code. And it was coming from a low base because I had no background at all in any computer science. This is what I did. I was a journalist, so I could do things like produce podcasts, edit video, take pictures, write text articles, but at that point I couldn't code. And he spent some time with me and gave me the confidence to apply for a job working with software engineers, making things like this. So, not Elton John, we didn't make Elton John, but Ben, if you saw the talk at 2 p.m, Ben would have you would have heard that Ben explained how he made the little flag on that bar to highlight the key moments in live TV on iPlayer, and I work with him in News Labs, which is the innovation lab in BBC News. So what Paul, my brother, didn't explain to what wasn't clear to me when I started the job with them was that Paul is exceptionally talented at explaining software engineering in plain English. So I started a job and I found out I couldn't understand about 1 in 5 words. I went on to, part of my job is that bridge between the non-technical and technical worlds and translating that for the non-technical people and translating the non-technical people's problems for the technical people, and that gave me a bit of empathy around that, and I thought I'd teach you a little mental trick. It's really simple. I want you to imagine somebody you know, somebody who isn't stupid, who you don't think is stupid, right? They don't have to be a genius, but they are not technical in any way. It could be your uncle, your niece, your cousin, your neighbor, your friend. Just imagine them. Imagine their face in your head. Imagine where you are. It's just done something really weird. Imagine where you are. And then I'm going to read out some words to you. And I want you to pick one of the words. And I want you to imagine how you would explain that word to them without using any technical terms. Okay, so it's not going on to the next word. Okay. Oh, you're going to see them now. Okay. Okay, it's done something weird. So I'm just going to read the words. So, Lambda, S3 bucket, ticket, backlog, AWS, IDE, pull request, DynamoDB, JSON, API, refactor, pip install, NPM, stand up, okay, repo, MVP, Kanban board, full stack, user journey, pipeline, runbook, GitHub. You liked GitHub?
That was funny, yeah.
When I first heard GitHub, I was like, are you insulting me? What's going on? Agile, the command line. I've got a few more, actually, that I heard just now. Pass. How do you describe pass? How do you describe, say this in a different way, run that command? There's tons of them, so I hope you picked one, and And I want you to reduce your explanation in your mind down to maximum 3 sentences, fewer words if you can. And then I want you to link up with me on LinkedIn. And, oh, it's not there yet. And it's just the last one now. And send your explanation to me, and I'll share them. Thank you.
Oh, I'm setting a hard task this evening. I don't know that I can do that. Maybe I'll try and pick an easy one. I'm not sure there were any easy ones. Okay, it's now another of lovely people who came to my workshop today. So I've had a sort of sneak preview of some of this. Rob Bresciano is going to talk about pushing the envelope and doing extreme 3D printing with Python. So a quick round of applause for Rob, please.
Hi. Thank you so much. That was 10 seconds. I'm Rob, and I like 3D printing by melting plastic. It's called fused deposition modeling. This is a 3D printer. It's printing a boat called a benchy that we use to benchmark our 3D printers. And what's the envelope? What are we pushing here? Well, this is actually, if you don't know the phrase, it's terminology from aerospace, from flight, and it's what pilots refer to when they're talking about exploring the physical limits of the system, the airframe, the plane that they're flying. How much can we do with that plane? And this is my jet. So this is what I want to push to the limit. What are the limits for 3D printers? Well, we can print pretty much at the maximum quality now with even fairly reasonably priced printers like this. So what we're doing is we're trying to print faster. And one of the ways that we do that is by adding a Raspberry Pi to do the thinking for us so that we can think faster. So that's not bad. What are we doing now? This is a real-time video. The last one was sped up 20 times. And this is a printer by a team called Voron Design. They design open source printers, so you can go and download this printer. It's GPL3, and print it out at home. This one's quite heavily modified because this guy is pushing the limits of what he can do with his printer. All of these printers are running a firmware called Clipper. I didn't write this. This is not my printer. I make these printers. I use these printers. I have a lot of fun with them, and I want you to be excited about them as well by seeing where the world of plastic melting has got to since maybe the last time you saw it. And this really blew my mind when I started seeing the speed that people were printing these, and that's what really got me into it, was these speed boats, these benchies being printed so fast that you can literally watch something coming together in like half of the time that we've got for a lightning talk. So why Python? What's the Python doing here? Well, we've got a Raspberry Pi that we're plugging into our printer, and instead of the printer having to do any heavy lifting, thinking about how to print that boat, the Raspberry Pi is planning all of the motion. It's thinking about the acceleration of the tool head. It's getting it up to cruising speed and then cruising over a move and then decelerating ready for the next move. And all of that careful planning is done by that Raspberry Pi. There are other things that we can do once we've got Python in the mix. So we can attach an accelerometer to the tool head, for example. We can measure the resonances of the printer, and then we can start doing really clever things like not printing at that resonance, so our printer doesn't ring, and we get higher quality. And this lets us really push the envelope and get super high quality prints super fast. So what else can we do when we've got Python? Well, it's actually really helpful. Once you've broken all of the thinking out to a Raspberry Pi, you can plug in multiple microcontrollers. So now you can start having printers that are distributed systems running on techniques like a CAN bus for multiple microcontrollers, one of which drives the extruder, say, and one of which drives the gantries, and you can make really clever new printers very easily. I'm making a printer at the moment called a Dueling Zero, which is a totally new architecture of printer where it has a second gantry. So we can have two tool heads moving completely independently, and that was made by one person pretty much who's taken the Clipper source code, the Python code that runs on the Raspberry Pi, and added about 200 lines to define a new kinematic to the Clipper system, which allows him to drive his dual gantry printer. It's all open source. He's published the printer, and now I'm building one, and I'll be one of the first 5 people in the world to have this amazing printer because of this open approach and the use of Python to allow people to do really rapid prototyping, not just in the things we're making, but in the way that we're making them. So going back to my aerospace analogy a little bit, I wanted to show this with you today because it's exciting to me. I think it's a really exciting time to be in 3D printing, and the Wright brothers was the first powered flight. Everyone knows that, right? 1903. I looked at when the first melting plastic 3D printer was. That was in 1992. So we're 31 years after that. What was 31 years after the Wright brothers? I went and had a look, because I didn't know. And it was an aeroplane, well, lots of things. It was a hugely interesting space to be in aerospace at the time. One of the planes that stood out to me was the Douglas DC-2. It's not a particularly exciting plane in and of itself. It was only manufactured until about 1939. But it was the forerunner to a plane 2 years later, the Douglas DC-3, which was one of the most successful airplanes of all time and is still in service. You can still fly on a Douglas DC-3 today. So that's what I've got for you. You can do this, get into it. I love it. And thank you very much for having me. If you want to come to learn more about 3D printers, come to Oxford. We've got the Sanjay Mortimer RepRap Festival. It's going to be awesome. It's really cheap. So if you're local, come and see it. Thank you.
Thank you, Rob. That is absolutely amazing to me. I think the last time I printed one of those boats, it took 2 hours. I can't really remember it. It took so long that I haven't printed another one since. So now we've reached, sadly, the last talk of our evening. But we do have more lightning talks tomorrow. So please feel, if you have an idea, if you've been inspired by something this evening, please write a proposal. Remember the title, description, name, and Discord username so that we can get in touch with you. And then put it in one of the buckets that we have by the reception desk. And now I know after the lightning talks this evening, hopefully many of us are going to go away and socialize with other people that maybe we've met during the conference. And we might have to choose somewhere to go. And so it was a pretty logical decision, I think, to make this the last talk of the evening. Dimitra, is that correct? Yeah, Dimitra is going to tell us how to look for the optimal pub. So a huge round of applause for Dimitra, please.
Hello. So I commonly have this problem with my pals on a Friday evening when we all finish work and we're looking for a place to go. The question is, do I travel to you? Do you travel to me? Should probably pick a place in the middle. But how do we actually pick that place in the middle? So to solve this problem, we're going to have to solve a few technical challenges, actually get the data, figure out how to do this multi-person routing, and sort of define what optimality means in this context. So for the data, I don't want to advertise different pub chains, but they do kindly post a list of their pubs on their websites. So we're going to go and scrape those. For the first one, it's really quite simple. You just post, you do a GET request to the pub. It returns 200 status code. And then we can use Beautiful Soup, which is an HTML parser, to parse the data and essentially extract all the addresses from that. The second pub chain is not as cooperative. We do this GET request, and we actually get forbidden error code. This is because the default user agent of requests is very unconspicuous. We can, however, just hard code some headers into our script to trick the website into thinking we're a browser. It does get even more difficult later on because this particular pub chain actually gives you loads of JavaScript, which requests clearly can't execute. This we can fix by using Selenium, which is actually a Java software for testing websites, but we can use it, or rather abuse it, to essentially scrape the website, load the JavaScript, execute it, and then pass all the addresses. So this is what the data looks like. The reds are clearly quite dominant in East and West London. Greens are all about the central London, and blues are kind of all over the place. You can probably guess what pub that is by this point. So there's about 300 in London. Now we need to figure out the travel times. This is not super straightforward because we also, to make this practical, we have to figure it out for transit, like buses and tube, as well as taxi, which can be a nonlinear function because of congestion and the like. So we do have to use an API. The problem with this is, as I showed, there's 300 different pubs. If we have 10 participants that want to find this optimal pub, there'll be 3,000 requests to figure out how to get to every single pub to then be able to compute the minimal time. So it's 2023, so let's build a machine learning model instead. We do have to use an API as an upfront cost to sample all these points as to how to get from point A to point B. And we build a model that looks like this. It's not particularly interesting. It's just a small neural network. We feed it start coordinates, end coordinates, and a cyclically encoded time. And we can get different times in minutes, how long it takes to get from any point A to B in London. As you can see, the metrics are actually not too bad. Walking, as expected, is kind of the best. And then transit is kind of hard to learn, I suppose. So for optimality, we can compute the lowest time once we know how every person can get to every pub and how long. But you can think of a case where this might not be optimal. For example, if you have 3 participants, for one of the participants it takes 60 minutes to get to a pub, for the other ones it's 5 minutes. That's a total of 70 minutes. It might be more desirable for everyone to travel half an hour, so you get to meet the other participants in half an hour rather than in 60 minutes, as in the first case. For this, we can use a minimax algorithm. It's got a very convoluted explanation in Wikipedia. I'm afraid I don't have time to explain it, but it solves that specific problem. So for my particular use case, there's 4 participants here. The green dot, the green marker, is the sort of minimax solution, and the red marker is just the minimal time solution. You can see how we all get to meet about 12 minutes faster with the minimax solution, even though it takes a little bit longer overall. Unfortunately, we won't be using this algorithm tonight because we know we're going to be going to the Tiny Rebel anyway. Thank you very much.
Yep, that's where I'm going. Well, thank you very much for enjoying this lightning talk session. Thank you so much to our speakers. We had 13 speakers this evening. Out of the main lightning talks, we had 6 experienced speakers and 6 brand new speakers. So can we have a massive round of applause for all of our speakers this evening? Again, that would be fantastic. And thank you to you for keeping the energy up the whole evening. I know it's been a long day and we've all had our brains kind of zapped with huge amounts of information and conversations, like more talking than we usually do in a month. Well, hopefully that will continue at Tiny Rebel. So my name's been Mark Smith. I've been your MC. Thank you.